Hello guys, welcome back to my channel, Boy. In this Talk with ChE segment, I have invited a chemical engineer from Brazil, Lucas Teixeira. Hello, Lucas.
Hello, Harry.
So,
Very glad to be here.
could you give a brief introduction about yourself?
Of course. So my name is Lucas. I'm from Brazil. I'm a student in the chemical engineering field. Now I'm the final year and doing some credits for the master degree. I'll work in a chemical engineering firm for almost 2 years from now.
Wow,
And chemical engineer is definitely what I love to do.
nice. So, today we will discuss a very interesting topic. This topic comes out from Lucas' recent post on LinkedIn with the title Excel versus Simulator. The post was very booming at the time. Maybe I can share my screen right now. Yeah, here. You can see, uh, even though it is just a screenshot of his Excel, but he got around 600 likes with 73 comments. I never have a post with this much like and comments before. So, wow, you have a really good job. So we can say that many people found this post really interesting and insightful. So Lucas, can you tell me what makes you post this topic on LinkedIn?
Yeah, actually, I can say that you made me do this.
Oh wow.
Uh, as I follow your work, I see that we are in a very globalized era. So I just want to be part of the international chemical engineering, and I have to show myself what we Brazilians can do. Awesome
Nice.
to to help grow in the field. And but I can say that this specific post has I wasn't I had no intention of doing such a noise, and I get impressed that people really liked it. I think pump is the cool topic that everyone likes most because it's common to other engineering, right? So civil engineering, chemical, mechanical, everyone learns this in college, and maybe the engagement from LinkedIn was due to the strong connection I'm doing. I'm trying to connect to as much as process engineer from the world to follow their work. And I feel that there are very few people that it is a junior level like us, and we also can do an impact for the world.
Okay, that's a very interesting one, Lucas. I will give a short little introduction. So, what Lucas did on LinkedIn, I think this technique commonly called by simulation validation. Validation for me is very important when we are conducting a simulation study because we may have an unrealistic result from simulation, but there is no warning or error shown in the simulation. Do you ever found that, Lucas?
Yes, I already did some big mistakes that would explode somewhere if you was to design for a company. So that was the goal, to see how the simulation works, found out the steps. I think the easiest way to learn, to real learn the thing is when you do on your hands. You actually do the work, not just rely on the simulation results. And to validate is the tough part.
Yeah,
Sometimes you don't know how to get there,
correct.
and
Yeah.
but my LinkedIn post was very simple.
Yeah. Therefore, we should validate the result so we can make sure that the result is not violating any best practice or any basic engineering concept. So I think that's it with my introduction. Without further ado, Lucas, you can share your work.
Okay. So what I'm trying to do is actually learn how to manage the Aspen simulator, and I'm following a book. I don't remember exactly who authors was. I think his name is Juma. It's a very
Juma
cool book.
Haidari.
Yeah,
I
we
also read
can
that book.
very good book, simple, and the steps are very clear. So it was from the chapter of pressure changers. And the first exercise was to calculate the power required for pumping 40 tons per hour of water in a temperature of 20 degrees Celsius, pressurized it from 1 to 6 bar. And the pump had 60% of efficiency. So here, what I did was specify my inlet. Wait. My inlet here. So as you can see, it's a 20 degrees Celsius at 1 pressure bar with the total flow rate as following the exercise. So in the main flow sheet, I specified my discharge pressure and my pump efficiency.
Okay.
Running the simulation just to validate it again. We have this network required. So that was my big goal, to find how to get in this number. So what I did, as Juma already explained, with the hydraulic power formula, you can actually do have your network required. And I let these long decimal places here just to show that this is the right way to found the result that was given in the simulation.
Yeah. So how do you develop your spreadsheet? You use, I think, a simple equation there. Density times gravity, and then the h. Where do you get the h? The head,
Okay.
I guess.
Yes, I think this is I feel this part with data from the simulation. So the head here is from the simulation, the flow rate as in a volumetric form. I had to do some conversion here in the formula. So here is the pump is pumping 40 tons per hour, and the efficiency specified, and the formula gave me the exact number.
Yeah, that's very interesting, and it shows that the simulation runs exactly with your spreadsheet calculation. Really
Yeah.
nice. So I think there's the next part in the B. Could you explain it as well?
Yeah, I did not show in my post, and it was to calculate the pump again, but now with the characteristic curve. So the exercise gave me the pump curve as I plotted here, and I did the manual calculation to see if that was close to the height, the height from the pump, and it actually is. As you can see here, it's 51 almost, and doing the graphic form, we are almost there. And with the rating mode, we get pretty close results. Here, the network required was 8.2, and here previously was 7, almost 8.
Yeah, That's right. I think there is a small difference because on the first simulation, you specified the outlet pressure by 6 bar, where in the second one, you let the simulation works for that. And with the pump curve given, it is not 6 bar that uh, the simulator calculate. So you can see there it is 5.18 bar. So yeah,
Yeah, and
we,
this is the simulation that we usually do working in an engineering company, right?
yeah,
Sometimes the equipment already exists, and you get the data to see how it works in a different specification.
yes, you're right. Um, in as a consulting company, we get this curve more rather than we input the discharge pressure, right? Because we have the pump already with the data sheet and we input it into the simulation. Okay, so the next one, uh, you said that you developed the data sheet, so maybe you also can show that.
Yeah, my big goal here is to validate the calculations in the pump. So I can do a calculation log with all parts specified. And when I do some work, when I need it, it can help me and it is validated. So that's my big goal, to construct this spreadsheet to do actual job.
Yeah, and in the design case, you can use this data sheet maybe to a vendor to buy new pumps, or also you can record the existing pumps. So many use that with this data sheet, isn't it?
Yeah, thank
Oh,
you.
yeah, really nice job, Lucas. And me myself thinks that this is very important for simulating it in a simulator, because you cannot 100% trust the simulator. They sometimes also have mistakes that may be unnoticeable by us as a chemical engineers. That's why this validation steps is very important.
Yeah, and working in an engineering company, the tools already exist, but
Yeah,
someone did it, and anyone can input the data, but what is actually happening? I think the only way to learn is when you do on your own, and that's what I'm trying to do here. It will take some time. It's very time consuming, but I'm learning a lot. I'm learning the limits of the formulas, what I can and I can't do it with an specified system. So that's been very, very good for my learning.
okay, thank you, Lucas, for your explanation and for your time. This marks the end of our discussion. Thank you for watching. If you like it, please subscribe, like, and share this video. And see you on the next talk with ChE session. Bye bye.